The big bad wolf, however, has successfully digested Dave and blows down James's house of sticks and begins to consume James. After eating James, the big bad wolf began to make his way down to John's house. John, in his house of bricks, was very confident that the wolf would not be able to blow his house down. Although he was confident, John still began to set up a defensive perimeter, all the while keeping an eye on his global positioning system, marking the progress of the big bad wolf.
So here we have the triangle of which the houses are set up of the pigs, and we just need to find the length D right here. So all we have to do is use the Pythagorean theorem to find that length. So as in this x right here is 5, so you have 5 squared plus this y right here, which is 50. You square that equals d squared. Now if you add these together, you get 2,525 equals d squared. Now to get rid of the d squared, you square root of this, you square root that. So then your answer for d equals 50.25 miles.
Okay, so John the pig has his global positioning system. We know that. And he sees the wolf, the big bad wolf, and he's coming towards James's house, or John's house from James's house. And since John has the global positioning system, he sees the wolf at different positions in different time intervals. So it takes the wolf, or it will take the wolf, approximately 15 hours to get to John's house. And we'll see how John figured that out. But throughout that interval, John takes calculations and he determines the wolf's position at each hour. So now I'm going to chart the different points that John took of the wolf and his position in relation to the zero value of x and of y, and the zero value of y is at James's house. So the y values represent the distance from James's house en route to John's house. The x values represent each hour consecutively. Okay, so now I have the dots pointed and the positions pointed. Now I'm going to draw a line that resembles the curve of his position. This is a position time graph. It's not perfect, but it resembles pretty well the wolf's position at that point in time, at each point in time. So now what we're going to introduce is the first derivative in a graph form. And by doing that, you take the slope at each point. So in order to find the first derivative, you need to take 2 points and find the slope between those 2 points. And then that slope is the point of the first derivative. And I'm not going to graph it out because we're short on time, but it's important that you learn how to do this. And if you're going to do this, you take 2 points, such as these, between 1 and 2. You find the slope and say this slope it's around 2. And so you take that, and so the first derivative point would be 2 at 1. So it'd be somewhere around there. And I'm going to approximate the first derivative. It would look something like this. Okay, so the first derivative, if the original function represents position time, so change in x, then the derivative, the first derivative, represents velocity, if it's his speed, so it's how fast he moves from point to point. So this represents velocity. Now, if we do the second derivative in this case, if the first derivative represents velocity, it represents the changing of velocity. So that would be acceleration in terms of physics. And in order to show the acceleration, it would be the same process as you do to take the first derivative, but it's called the second derivative. And our graph doesn't necessarily show the negative, but the second derivative would be in the negatives. And because there are some slopes on this first derivative that are negative, such as these that I'm pointing out. So at these slopes, the derivative, or the second derivative, would be in the negative and below the x-axis. So it would be in points like these, maybe a little bit steeper right there, maybe a little bit steeper right there. And so the second derivative might look something like this. That's a very rough approximation, of course, but you get the point. It's the same process with the second derivative as it is with the first derivative. Now, see, this represents acceleration. Okay, so once we figure out, or John figured out the time that it would take in order for the wolf to arrive at his house, it was too late. And so ends our story of the three little pigs and the adventures that they have with the wolf, or lack thereof, since John ends up being consumed in the end.
Oh, good.
Thanks for watching.